day, everyone. We are the Gold Diggers Group, and we are now here in the chapter 5, which talks about the augmented reality. So, in the end of this lesson, we're going to learn all about the augmented reality. With this topic outline, the introduction to augmented reality, virtual reality versus augmented reality versus mixed reality, the architecture of AR system, AR components, AR architecture, AR server communication, AR system clients, AR system database server, AR devices, and the application of AR system in the field of education, medical, entertainment, military, engineering design, manufacturing, maintenance and repair, and the collaborative AR.
Introduction to AR. Augmented reality is a general term for a collection of technologies used to blend computer-generated information with the viewer's natural senses. So why is AR or augmented reality an interesting topic? AR is interesting since it allows the user to experience the real world with the virtual objects in it. Namely, seeing and handling virtual objects in the real world makes AR attractive, and such a concept may offer diverse possibilities for many applications. Despite such as attractiveness of AR, the realism of virtual objects has not come close to the user's expectation, which is the thought of as a negative aspects of AR. Therefore, AR research has focused on achieving the realism of virtual objects to make the user feel more immersed in the AR world. The realism of virtual object can be considered from two different standpoints: appearance and behavior. Using a rendering method such as photon mapping, an augmented object can be made to have a realistic appearance. On the other hand, using a physical law, the motion of virtual object can be simulated in a physically correct manner. The goal of augmented reality is to improve and enhance our perception of the surroundings by combining sensing, computing, and display technologies. Most AR research addresses human vision, as it is generally considered to be our most important sense. Visual systems are also the focus in this overview, but it is worth noting that other stimuli such as feedback from auditory, tactile, or olfactory displays may be equally or even more important, depending on the specific scenario and individual. There are three classical and widely used criteria for AR system. First is combined virtual and real. AR requires display technology that allows the user to simultaneously see virtual and real information in a combined view. Traditional display can show only computer-generated images and are thus insufficient for AR. Second, registered in 3D. AR relies on an intimate coupling between the virtual and the real that is based on their geometrical relationship. This makes it possible to render the virtual content with the right placement and 3D perspective with respect to the real. The third one is interactive in real time. The AR system must run at interactive frame rates such that it can superimpose information in real time and allow user interaction. The fundamental idea of AR is to combine or mix the view of the real environment with additional virtual content that is presented through computer graphics. Its convincing effect is achieved by ensuring that the virtual content is aligned and registered with the real objects. As a person moves in an environment and their perspective view of real objects changes, the virtual content should also be presented from the same perspective. The reality-virtuality continuum spans the space between reality, where everything is physical, and virtual reality, where virtual and synthesis computer graphics replace the physical surroundings. Mixed reality is located between them and includes AR and augmented virtuality. AR adds virtual content to a predominantly real environment, whereas augmented virtuality adds real content to a predominantly virtual environment. Although both AR and augmented virtuality are subsets of mixed reality by definition, most of the research in the area focuses on AR, and this term is therefore often used interchangeably with mixed reality. AR techniques exploit the spatial relationship between the user, the digital information, and the real environment to enable intuitive and interactive presentation of data. An AR system can, for example, achieve the medical see-through vision by using a spatial display in which the images displayed by the computer are seen overlaid on the patient. Samples of augmented reality. First, the real desk with virtual lamp and two virtual chairs. Then, the real-time ultrasounds image over a patient's body parts. Then the third one is a ultrasound scan with a pregnant woman body to allow the physician to look into the body for a view of the fetus.
What is virtual reality? Encompasses immersive experiences and content via a VR headset or HMD head-mounted display. The content is 100% digital and computer generated. So in other words, virtual reality refers to computer generated simulations in which a person can interact with an artificial three-dimensions environment using electric devices such as a special goggle with a screen or a gloves fitted with a sensors. There are three types of virtual reality devices. First is tethered. It is a headset to display device to another device, like a PC or a video game, to console and provide a virtual experience. Next is standalone, are an all-in-one devices that can power virtual reality on their own, with no computers or no phone needed. Smartphone, also called mobile virtual reality or virtual reality viewers, includes a number of high-profile brands in the VR space, such as Google Daydream. Let's proceed the pros and cons of using virtual reality. First is better than reality. So in virtual reality technology is used in a video games and user gets feelings that he is in another world. In video games by VR controller, transmissions of vibrations and also other sensations has been done. Second is connect with people. Virtual reality gives chances to communicate with the people you don't know in your real life. So, makatabang ni siya to forming the new relationship in a more efficient manner as compared to the real life. Also, users came to know about different types of people and get connected with them. Third is give details view. For example, virtual reality makes tourism sites more interesting and easy. It's give the details view of the place where you want to visit, so viewer can plan their trip by seeing the real locations of that place. Moreover, user can also see the important landmarks as well important places in which they are interested to go. Fourth is users have some experiences. So the virtual reality technology makes users feel that they experience the real locations and hearing the real sounds and seeing the real things. Many people have the feelings to use more and more virtual reality technology. Films which are produced by VR or virtual reality gives the permissions to the audiences to view the whole surrounding in each and every scene. Thus, it's create interactive viewing experience for the audiences. Let's proceed to the cons. First is high cost. One of the main cons of virtual games is that it's not possible for everyone to afford it. It is too costly and people who cannot afford this will be left out using this technology. Second is users addict to the virtual world. These users get addicted to the virtual world and navigated the non-virtual environment. So, these addictions can cause various health issues for them. Third is training in VR environment is not real. So another con of VR is that a person who has been trained in VR environment may be do well in that environment, but he cannot perform well in the real world. So dili siya makahatag og same results in real life situation as compared to the virtual reality environment. So fourth is lost in human connections. This is where somebody relies more on virtual reality for social interactions than in real life. As a consequence, this could create some improper associations that are not part of the real life social setting and can ultimately lead to depressions and these associations depending on the severity.
What is augmented reality? When we say augmented reality, it overlays computer generated content on top of the real world. This superimposed digital overlay can superficially interact with the environment in real time. AR is primarily experienced via wearable glass device or through smartphone applications. So this augmented reality, it combines real and virtual worlds, real-time interaction, and accurate 3D registration of virtual. So the primary value of AR is the manner in which components of the digital world blend into a person's perception of the real world, not as a simple display of data, but through the integration of immersive sensations which are perceived as natural parts of an environment. Augmented content doesn't recognize or interact with the physical objects within a real-world environment. However, it does enhance the user's experience. So what makes AR different from virtual reality or mixed reality is that AR is believed to have some of the biggest potential for mass consumption. It can be delivered on hardware that we already own and use today, such as smartphones. So some of the categories of AR products are wearable AR glass like smart glass, smartphone, AR and other AR headsets.
So, what is mixed reality? Mixed reality sometimes refers to as hybrid reality. It is the merging of real and virtual worlds to produce new environments and visualization where physical and digital objects coexist and interact in real time. Mixed reality combines several technologies into one wearable device. This wearable device will allow you to manipulate objects and interact in real time. So, as you can see in this illustration, mixed reality combines elements of both augmented reality and augmented virtuality. The real world and the digital objects interact. So mixed reality removes the boundaries between real and virtual world using occlusion. The computer-generated objects can be visibly obscured by objects in the physical environment from the user's point of view. Mixed reality is a digital overlay that allows interactive virtual elements to integrate and interact with the real-world environment. The key characteristics of mixed reality is that the synthetic content and the real-world content are able to reach each other in real time. To better understand mixed reality, let us all see these following examples. So the first example is the mixed reality in engineering and medicine. In mixed reality, you interact with and manipulate both physical and virtual items and environments using next-generation sensing and imaging technologies. Mixed reality allows you to see and immerse yourself in the world around you, even as you interact with a virtual environment using your own hands, all without ever moving your headset. The next example is the mixed reality in entertainment. As you can see, this gives you the ability to have one foot or one hand in the real world and the other in an imaginary place, breaking down basic concepts between real and imaginary, offering an experience that can change the way you game and work today.
Okay, so next is the architecture of AR system. The AR components are scene generator, tracking system, and the display. So scene generator is the device or software responsible for rendering the scene. Tracking system or monitoring system is one of the most important problem in AR system, mostly because of the registration problem. The objects in the real and virtual worlds must be properly aligned with respect to each other, or the illusions that the two worlds coexist will be compromised. So for the industry, many applications demand accurate registration, especially on a medical system. So next is the display. A fundamental characteristic of AR systems is that they allow the user to see a combined view of virtual imagery and the real objects. So the technology for AR continues to be implemented and option depend upon design choices. So a lot of show unit for AR are HMD or the head mounted display. The AR system is built on a multi-tier client-server architecture. Tiers are characterized by the type of processing that takes place within them, or in the way one tier communicates with another. So client tier contains AR system client. Most clients present information to application user and receive input from them. But the tools for migration and application development are also client. So client tools are used to access, manage, and build application. So ang client mo ay mag-handle sa presentation ug sa application. So next is the mid-tier. Mid-tier contains component and add-in services that run on a web server, enabling user to view application on the web. So the mid-tier lets you access the AR system server from a browser and makes web services accessible. Next is server tier contains AR system server, which controls workflow processes and access to database and other data sources in the data tier. This tier also contains server-side application, such as approval server, email engines, and the flashboard server. And the C and Oracle Java plugin server which plugins. So the AR system server runs application and workflow. It also enforces business logic. So last is the data tier. Data tier contains database server and other data sources that can be accessed by the AR system server. So the database server acts as a data storage and retrieval data engine. So also, ang data tier is hold the data that application create and manipulate. Next is the AR system multi-tier architecture. To provide scalability and increase reliability, you can connect a group of AR system servers to the same database and manage them as a unit by configuring a server group. Server group act as a single server to support the application that they run. Servers in the server group can be configured to spread the load of shared services, and they can provide backup to each other to ensure that those services are always available.
High-level architecture of the ER system use distributed server option to build large-scale distributed environments that behave like a single virtual system. This enables you to share common information among servers and to keep that information consistent. ER system in a distributed environment because the multiple layers of ER system are independent of one another. You can combine operating system platforms to fulfill different functions. The heterogeneous environment enables you to mix and match client and server platforms. ER system functional components. Presentation. The presentation layer is responsible for presenting services and displaying data to clients through various interfaces, which include the following: browsers, cell phones, PCs, digital assistants, BMC Developer Studio, API programs. Business processing. The following business processing components manage the data entered through clients, perform services based on your business processes, and enforce your business rules, which include the following: mid-tour, system server, server functions such as the distributed server option, and approval server, Atrium integrator, web services. Data storage. system supports Oracle and Microsoft SQL Server database for storing data. For each of the relational databases, table owned by other systems can be referenced as if they were owned by system. System client-server communication. Number 1. Communications between clients and the system server. All clients of system server communicate with the server by using remote procedure calls. On top of a TCP/IP transport stacks, the system web server communicates with the browsers using hypertext transfer protocol or secure HTTP. Number 2, communications between system servers and database servers. From the perspective of database server, the system server is a database client. system server uses the JDBC to connect to the database. When a system server is installed, the installer specifies the type of and location of the database server that informs the server which JDBC driver to be used. The server uses the JDBC connection pooling to allow multiple database connections in parallel. The server process compresses many threads to support user requests and share the connection pool. Number 3, many-to-many connections. In an system environment, one system server and theoretically support any number of system client connections, limited by network bandwidth and server host and database performance. The clients can be on any mix of platforms. Similarly, an system client can be connected to any number of servers at the same time.
AR system clients. AR system clients provide user interface facilities available from various platforms, including the web. AR system clients are available for a number of operating system environments, as listed in AR system client server architecture. For each operating system, the client is composed of a set of native applications or tools that use the standard user interface conventions for that environment. AR system clients can be broadly divided into user client and developer clients. The user clients. Through the mid-tier, users can access the AR system in a browser. Using the web-based interface, users can submit and modify new requests, search for information about requests, and generate reports. For the developer clients are used to create, modify, and extend augmented reality system applications. And in addition, the integration clients. BMC and its partners also offer the following tools for expanding the capabilities of the core AR system. These tools act as clients of the AR system. The knowledge management, network management platform integration accessories, and the systems management integration utilities.
Good morning, my name is Raymar Duzon. My assigned topic is all about the AR system database server. So, BMC Remedy AR system uses standard relational database engines for the actual storage and retrieval of data. Architecturally, the database service is an independent set of processes that are completely separate from the AR system server processes. The AR system servers is a set of processes that run on an application's server host. The server is available for each of these operating systems. The Hewlett Packard HP UX, the IBM AIX, the Linux Red Hat and Novel SUSE, the Microsoft Windows Server, and the Oracle Microsystems Solaris. So AR system database server is a BMC Remedy. AR system can also work with data stored in external databases and other data sources that are not managed by BMC Remedy AR system. BMC Remedy AR system accesses the data sources through view forms. BMC Remedy AR system a workflow components can search for the records requests in the AR system database and act on the results for the search. Clients can use the following types of searches. So these are the following types of searches. First, we have the query by example or QBA. We have the advanced search, the predefined, and the recent type of searches. So talking about AR database system, what is really the use of an AR database server? Because the AR system server manages all the workflow, applications are independent of the database. Therefore, any applications created on the AR system server running on type of database can easily be moved to a server running in a different type of database. So the DBMC provides a simple export or import utility for this kind of purpose. An administrator can create and store searches that are commonly performed by users. A user can define the personal searches for forms to which the user has an access.
Hi, I'm Georgianis Bisada and I'm going to report the ER System Database Server. ER System uses standard relational database engines for the actual storage and retrieval of data. Architecturally, the database server is an independent set of processes that are completely separate from the ER System server processes. Physically, the database server processes can be running on the same server host as the ER System server or on a different host. The database server can be any platform that a database engine supports. A. Support for an external database. ER System can also work with data stored in external database and other data sources that are not managed by the ER System. ER System access these data sources through view forms. In addition, ER System can use ER System Database Connectivity (ERDBC) to work with data not stored in database as if the data was locally owned. In other words, ERDBC plugins can be created and configured to enable access to data stored outside the database as if it were the tables owned by the ER system. B. Support for multiple database types. ER system is not a database application in the typical sense. All of the workflows are managed by the ER system server, so proprietary database features such as triggers and stored procedures are not used. An application created on an ER system server running one type of database engine can easily be moved to a server, running to a different database engine through a simple export and import process. C. Support for database searches. ER system workflow components can be searched for records or requests, and the ER system database can act on the result of the search. Client can use the following types of searches: query by example, advanced search, predefined, recent, and administrator can create and stored searches are the commonly performed by the user.
Hi, I'm Christine Basilis Colomba and I'm going to discuss the augmented reality device. The augmented reality device is an enhanced version of the real physical world that is achieved through the use of digital visual elements, sound, or other sensory stimuli delivered via technology. So ito ay binahagi sa atin kung gaano kahalaga ang isang teknolohiya. The four major classes of ER can be distinguished by their display type. First, optical see-through HMD. Second, virtual retinal system. Third, video see-through. Fourth, monitor-based ER and projector-based. Optical see-through uses a transparent head-mounted display to show the virtual environment directly over the world. It works by placing optical combiners in front of the user's eye. So, ito ay kadalasang ginagamit sa mga military and pilots to display images to assist with the target area. Virtual retinal system is a display technology that draws a raster display, like a television, directly onto the retina of the eye. The user sees what appears to be a conventional display floating in space in front of them. All images you see on the internet and images taken by a digital camera is the example of raster images. Video see-through uses an opaque HMD to display a merged video of the VE and view from cameras on the HMD. So ito ay ginagamit na machine upang malalaman kung may tumor ba ang isang tao. Monitor-based AR and projector-based uses real-world objects as the projection surface for the virtual environment. Projector-based AR is also well suited to multiple user situation. The alignment of projectors and the projection surfaces is critical for successful application. So, ang example ani niya is the operating room set up during the surgery.
Application of AR system. Augmented reality technology has many possible applications in a wide range of fields, including in education, medical, entertainment, military training, engineering design, manufacturing, maintenance and repair, and collaborative AR.
Hi, I'm Sheila A. Hagonos. I tackle about AR in education. AR in education, probably the most popular application for augmented reality in education, is the use of AR apps directly in the classroom. In this case, they can help the teacher explain a subject, provide a visual representation of the material, and help students test out their knowledge in practice. Here are some outstanding examples of augmented reality in education. AR apps for kids. For example, Narrator AR teaches children aged 3 to 5 how to write in a fun and engaging manner. The app enhances letters they write with captivating special effects and makes handwriting a truly exciting experience. Augmented reality in the classroom. Augmented reality can serve a variety of purposes in your classroom. This exciting technology layers virtual content on top of the real world, providing an opportunity for students to interact with content in a completely new way.
Example: the Curiscope uses the virtuality, a t-shirt embedded with a code combined with the company's app to give students a look into the human body. They can explore all of these systems and understand anatomy on a deeper level. Another example is the CoSpaces Edu, an amazing 3D creation web and app-based classroom tool that allows students to create in a 3D augmented and virtual reality environments. Finished creations can be viewed in virtual reality with the mobile device using the app, such as the iOS and Android. The Quiver Vision Amazing AR Coloring app. This app has a set of coloring pages that make cells pop off the page and let children spin a globe in mid-air. Quiver lets students go beyond the pictures in their textbooks to interact with the three-dimensional figures. Augmented reality and medical field. AR has the potential to revolutionize medicine. During surgery, AR systems provide medical imaging data and other patient information superimposed on the operation area in the most intuitive way. Furthermore, AR-aided navigation systems can reduce the risk of complications and improve the safety and quality of surgeries. AR education systems train the surgeons of tomorrow to acquire the critical skills, and AR rehabilitation concepts help patients to recover faster after interventions. Augmented reality could be applied so that the surgical team can see the CT or MRI data correctly registered in the patient in the operating theater while the procedure is progressing. AR and entertainment. The entertainment industry is one of the most dynamic and investment heavy on today's market. It is also one of the most active in absorbing advanced technology to make over more impressive shows, games, movies, exhibitions, and competitions. Augmented reality adds a new dimension to entertainment, allowing the audience to become active participants of the show instead of passive viewers. AR brings interactivity and engagement in the show, merging the real world with the virtual one.
My topic is all about augmented reality engineering design. ER engineering design. In the formative stages of development, ER enhanced the design software that help the developers to visualize designs, use 3D model holograms, and see how new or replace the components and parts that might fit on the existing products. In the recent article in Mechanical Engineering magazine, for example, it shows how AR allows designers to visualize new motorcycle cladding and a fuel tank cover on an existing bike.
AR in military training. The military sector has always been at the forefront of using emerging technological advancements for the purposes of training and combat enhancements. Tactical augmented reality heads-up display can improve the soldier's battlefield awareness, reduce the number of devices that must be carried, and help beat the tar out of your enemies more efficiently. All the crucial information, such as the spatial orientation data and the weapons targeting, is being superimposed onto the pilot's visor, so they do not have to look down at their panels all the time and have much better situational awareness. TAR looks like the night vision goggles, but it can offer much more possibilities. It can show a soldier the exact location and the positions of the allied and enemy forces. The system is mounted to the helmet the same way the goggles are and can operate during both night and day. So TAR basically replaces the typical handheld GPS device in goggles. As a result, a soldier would not have to look down whenever they want to check their GPS location. Augmented reality in manufacturing, maintenance, and repair. AR maintenance is the process of using smart technology to illustrate and train maintenance professionals on how to perform important maintenance procedures effectively and accurately. AR replaces classic methods of teaching such as training manuals, printed graphs and material, and even 3D models. There are three ways that AR can improve how manufacturers maintain and service machinery. First, better install and fix rates with AR instruction overlays. Second, unlock knowledge from subject matter experts with 3D experiences. And lastly, high service contract renewals and upsell opportunities. Collaborative AR. Collaborative AR approach allows multi-user to simultaneously share a real world surrounding them and a virtual world. The features of collaboration in AR environment will be identified. So collaborative AR systems have been built using projectors, handheld and head-worn displays. By using projectors to augment the surfaces in a collaborative environment, users are unencumbered, can see each other's eyes, and are guaranteed to see the same augmentation. AR addresses two major issues with collaboration: the seamless integration with existing tools and practices, and the enhancing practice by supporting remote and co-located activities that would otherwise be impossible.
Topic summary: Augmented reality. So augmented reality is an enhanced version of the real physical world that is achieved through the use of digital visual elements, sound, or other sensory stimuli delivered via technology. Virtual reality, also called a computer simulated reality. This refers to computer technologies using reality headsets to generate realistic sounds, images, and other sensations that replicate a real environment or create an imaginary world. Mixed reality, sometimes referred to as hybrid reality. It is the merging of real and virtual worlds to produce new environments and visualizations where physical and digital objects coexist and interact in real time. One of the most obvious differences among augmented reality, virtual reality, and mixed reality is the hardware requirements. And also, virtual reality is content which is 100% digital and can be enjoyed in a fully immersive environment, while augmented reality overlays digital content on top of the real world. And the mixed reality is a digital overlay that allows interactive virtual elements to integrate and interact with the real world environment. AR components, scene generator, tracking system, and display. AR system architecture, client tier, mid-tier, server tier, and data tier. AR system clients provides the user interface. The mid-tier makes the user interface available in browsers. The AR system server implements the workflow functions, access control, and flow of data into and out of the database. The database server acts as a data storage and retrieval engine. AR system functional components. First, presentation, business processing, and data storage. AR system client or server communication, communications between clients and the AR system server, communications between AR system servers and database servers, and many-to-many connections. The AR system clients, the user client, developer clients, and integration clients. AR system database server, support for an external database, support for multiple database types, and support for database searches. The AR devices, optical see-through, video see-through, and projection displays. The application of AR system in the field of education, medical, entertainment, military, engineering design, manufacturing, maintenance, and repair. And lastly is the collaborative AR.